Welcome everybody. So I have a question for you. As you can see, I am here in a flat world. This is the Redstone Ready preset in the flat worlds for Minecraft. And I'm wondering if you can tell me where in the world I am right now. Like, what are my coordinates? What about now? Can you tell me where in the world I am right now? Can you tell me what my coordinates are? So yeah, it turns out that looking at netherrack, based on the rotation, like patterns of rotations of the texture of netherrack and other blocks as well, can tell you um, where you are in the world. The rotation of blocks in the world of these textures is obviously supposed to be pseudo-randomly generated, but yeah, they are based exactly on your coordinates. So placing a block here, this block will have the same rotation on all sides for any Minecraft world. It'll have this same rotation in this same place. So yeah, if we know um, the formula to like how the game generates, how the game chooses how to rotate these textures, we can actually reverse engineer um, like from if we have a number of blocks like this, we can actually determine exactly in the world where we are. So, and it turns out right here I have a 6x6 of netherrack. Looking at these 36 faces, should be able to enough to determine this unique location in the entire 60 million by 60 million world, actually. Which, yeah, I think that's pretty incredible, actually. So I'm going to talk a little bit about how the game does this, how the game chooses the rotation, um, what exactly happens, and hopefully you can understand it a little bit better. So first of all, I want you to take a look at these textures. Like, for example, look at this block here. You'll notice this sort of L, this black L right here. Um, you can see it's in the top right of this block. If I go to this block, you can see it's in the lower left-hand side. So this is this texture right here, where I'm looking right now, is this block rotated by 180 degrees actually. If you see it's this one, you could see the L is on the bottom right here, and this one it's on the top left here. So you may think, if you have random rotations on every side, uh, yeah, the game can have uh, 4 to the 6th, 4 to the 6th power, which is equal to, or I think 4096. So you think the game could possibly have 4096 different blocks, like different ways it could generate all the sides. But that is not actually the case. The game actually only has 16 different presets of ways to generate a netherrack block. And yeah, I'm going to show you a spreadsheet now. One moment. So if we look at this spreadsheet right here, I have type values 0 through 15. So there's 16 different types of types of blocks. If the game chooses to generate a type 0 at a certain location, that means if you are facing north, if you're looking north and you look at the top of the block, it will have a type 3 rotation on the top of the block. It'll have a type 3 on the bottom, and it'll have type 3 for on the west, east, south, and north faces of the block as well. You may be wondering, what am I talking about with these types right now? So if we look over here to the left, I have these type names and IDs. So what I'm doing is I'm calling blocks that have, or netherrack block faces that have that little L formation that I showed you earlier that has that little L thing. If I go back here, I can show you again. So this L right here, blocks that or faces that have this L in the top left of the block, I'm calling that type 0. And blocks that have it in the top right, I'm calling it type 1. The lower right, I'm calling it type 2. The lower left, I'm calling it type 3. So there's 4 rotations, as you can imagine, and that makes for 4 different types of faces. So if we go back to that spreadsheet, yeah, I have that information here. You can see all the different, all 15 types. They have a specific set face value. So if you get a type 0, it's always going to have this face. And what I mean by these up north, down north things here is if you're looking at the top side of the block and you're facing north, this is the type. Like if you were facing a different direction, you could interpret it as a different rotation type. So that's why I'm talking about north here. Yeah, like if you're looking at the west face, you're always gonna. It doesn't really matter what direction you're facing. Well, you'll probably be facing the block actually. So yeah, that doesn't actually matter. So yeah, instead of 4,096 different types of blocks that could generate, you only have these 16 different presets. And yeah, I'm gonna go next into how the game determines which of these types to generate at a specific location. It is determined directly based on a block location. It would be the same. You'd have the same rotations in every world, and in the Nether as well, or the End even. So if we go over to this Java program that I wrote, I'm going to show this off for a second. I'm going to explain, if we go up to the top here, these 2 methods right here determine exactly how the game generates it. And I took it from the MCP decompiled code. And also I'd like to point out that for 1.12 and before and 1.13 and 1.14, there's actually different methods. There are different functions the game uses to generate the block faces. So yeah, in 1.12, I have this right here. So this method is called get texture type. You have x, y, and z coordinates of the block, and you have the version. If the version is 2, that means we're talking about 1.12, and this is the 1.12 method of generating. But if we're talking about 1.13, then it returns this right here. So if we're in 1.12, you can see this. It returns this get coordinate random call right here to this function right here, and you can see this right here gets modulated by 16. So that is what makes up the 16 types that I was talking about earlier. So it calls this function with the x, y, and z parameters, and we return this. Well, you could probably interpret as a pseudo-randomly generated long. So that's a 64-bit number. That's determined by. This is just. I took this from the function from the game code. You have x multiplied by this number, and you get an XOR operation with the other coordinates multiplied by some number as well, and then it multiplies it by itself. It's just presumed to be somewhat pseudo-randomly generated type thing. So yeah, we get this value, and then the texture type is determined by this casted as an int and right bit shifted by 16, and then we take the absolute value and modulate it by 16, and that's how we determine the type in 1.12. And in 1.13 we actually use this random object. So we set the seed to a value we get from here, right shifted, and then we return this formula, as you can see here. So yeah, but once we have the texture, like when we're looking at the block faces, in game, how do we like interpret this to these 16 different block types? And for that we use this compatible rotation method I made. So this generated type is the type 0 through 15, the 16 different types that we get from this get texture type method. And then we have a block face, and a block face just has an X, Y, and Z values, and we have a side, and a side is just this enumerator that tells what are the 6 sides of the cube it is, and we have a rotation. So that's what a block face is. And essentially here I just implement the Excel sheet that I was showing you guys before. Yeah, this essentially just implements that. Like, as you can see here, if we have a type 0, and like we know it's going to be the rotation, we only return true if the block face rotation is 3. So yeah, we know, if it's like we were looking at that. If I go back here for a moment, as you can see here for type 0, all the sides of the block will have a rotation 3, which means that the little L formation will be on the bottom left side of the block for all of those. So yeah, if we go back to Eclipse, this just implements that, essentially just implements checking that exact Excel sheet I showed you before, and that way we can tell if what we do in the code is we get the texture type, and if in a formation we know a specific location has a specific block face, we check if that generated type is compatible with that block face, like if that rotation is right for that location that we're checking. So yeah, in the main method here I just have a single threaded search. We're searching through a specified area. I'm searching like 20,000 by 20,000 area around spawn. I'm only searching at Y59. Or that was just one of my tests that I was doing earlier. That's why it's set to that. You can modify these to search in a specific area. Here you would build your formation. So right here I have an array list of block faces. So these block faces have X, Y, and Z relative locations to where you're searching, similar to my Bedrock Formation Finder. I'm sure a lot of you have seen that. You're familiar, hopefully, with these relative coordinates, what that means. You want to specify what side the block face is, and you also want to specify the rotation, so the 0 through 3 IDs that I was talking about before. So here's just an example of the formation. Later on I also want to mention this use all rotations. So if you don't know which direction is north, or if you just don't know the directions of, like, if you're looking at a screenshot of some block rotations or some block faces, and you don't know which direction is north, what you can do is you can just choose one direction and tell yourself that is north, and if you have this set to true, it will generate 3 other formations, and one of those will be in the correct direction. It'll have the correct direction as north, and yeah, so you can still find a formation even if you don't know the cardinal direction. Also, I want to mention for these programs that I'm showing off here, if we head back to Minecraft for one moment. So, like, what I'm talking about is, like, let's say we were going to define this as north, even if it's not north. So we say this is north. If you go right from here, this is the plus x direction when you're entering the relative coordinates for your formation. So this direction I'm going right now is the plus x direction. If you're going down, this would be the plus z direction. So yeah, remember that, down would be plus z, right would be plus x relative to what you would define as north if you don't know what is north. So yeah, if we head back to Eclipse, so we have this. It'll make the extra rotated formations for you. Here is just the search. It will check for compatible rotations on all of your block faces, and if they all are compatible, then it'll print it for you. So yeah, I mean, this is nice. So we have this program in Java running on this single thread, but thing is, like, this can take quite a bit of time to do all these calculations for your computer if you're running this on your CPU. Yeah, if you have, like, maybe, you know, you can use multiple cores, run multiple threads for this as well. But I wanted to make, like, I wanted to make a really fast search. Like, I was wondering how I could make this as fast as possible. So what I went with was GPU programming. So I used a library called OpenCL, and I implemented essentially this program in a C++ program using OpenCL, and OpenCL can run on your GPU. And so your GPU is really a lot better than a regular CPU at running things massively parallel. So if you want to do a lot of calculations at the exact same time, and you have a program where you can do that, running something on your GPU will do that very effectively. Yeah, I heard of people running like cryptocurrency mining and stuff on GPUs and for that, because I guess that was really effective for that. I heard about that a while ago. That's why, like, GPU prices went up a lot higher, or, you know, graphics cards, GPUs, same thing. So yeah, what I'm going to show off now is my implementation using OpenCL. So we're going to head over to Visual Studio, and so yeah, I used OpenCL to implement this to run on GPUs as well. Yeah, if I talk about some numbers a little bit, I was actually able to search in a million by a million, only a single Y level, but a million by a million, one direction search. So that would make for 1 trillion total locations. I was able to search that in about an hour, and my GPU isn't even that good. So if you're able to specify from, like, a screenshot or video, if you know what Y level your set of block faces that you could see for netherrack are on, then yeah, you could do really quite fast searches. You might even be able to search the whole Minecraft world if you have, like, a decent GPU, and if you really want to do it. If you could also, I don't know if I talked about this, but yeah, you can search multiple Y levels. Here in this program, I only have this X and Z length. These are only specified around the origin. So this would be 50,000 by 50,000 around the origin, from what you could see right here. Y range size, that's the number of Y levels it searches, and Y bin is the base Y level. So for 1 and 4, we're only searching at Y equals 4 for this search. Yeah, I also have the rotation, the formation rotation implementation here as well. So you don't have to know cardinal direction of your block faces either. So that's nice here too. Also, I have this version specified. 2 is for 1.12 and 3 is for 1.13. So this program can specify that. Yeah, what else? So here I have the formation in a array. So I'm going to explain a little bit about how you set this up in the array. Right here we have the face count. So I have 32 faces in my current formation here. The size of your formation array would be 5 times that. So we have 160 here, and I'm going to explain this right here. So you can see I have these 5 values on each line. The x value is this first value. Then we have the y value, the y relative value. These are relative coordinates, like in the Java program there. The z relative value. Then we have the face ID. Here we have the face IDs. I don't have an enumerator in the C++ program to specify that, so I'm just using these number IDs. And then we have the rotation, the same 0 through 3 IDs as before. So we have that here. Yeah, we have this all rotation Boolean. If you know the cardinal direction, then you don't need this. But yeah. So yeah, we have GPU kernels set up to run each of the to run the check at each location in the specified area. So maybe I could show that. I have the kernel, the OpenCL kernel. Kernel's written in Notepad++ here. So I have one for 1.12 and 1.13. I had, like for 1.13, we had the Java random implementation. So I actually had to look up like what you were calling doing a next long call. So I had to check out the implementation for this, and this get texture type function here actually does the whole work to return the what of the 16 block types it has here. So we could see here, probably most of you haven't ever done any OpenCL programming, but yeah, this is a kernel. We have to write the kernel in C, because yeah, that's just how it is, I guess. So I'm sending these parameters here. The faces, that is the array that we saw in C++ earlier. So we iterate through all of the faces. We have the face count here, and we check for compatible rotations for each of those. And yeah, if we find them all, then we have this found array to set our value to the location. Yeah, we also have this compatible rotation method, same as the Java program implementation earlier. So yeah, you can use all this. I did a decent amount of testing with this program. It should all be working correctly. Yeah, it'll be on my GitHub page. I'll have the Java program too on my GitHub page in the description of this video, so you can go get these programs if you want to test them out. So if we head back to Minecraft here. So yeah, so all this I was talking about, at least for, the 16 types and the rotation type IDs and everything, that was work I did with these netherrack blocks. So of course, netherrack blocks aren't the only types of blocks that have random rotations. Another example is the tops of grass blocks. So if you look at this grass block, take a look at this bright pixel, one off from the rightmost pixel right here. If we look at this next block, you can see, yeah, that's not on this one. Now it's here, it's rotated. So yeah, if we go back to the sheet I was showing off before, I also have a little information about grass here. But you can see for grass, I only have these 4 different types. And yeah, so what I was telling you about that that bright pixel one off the corner, that's actually the only corner that has a bright pixel one off the corner, and that's what I used to define these ones. But yeah, like I said, you can see this only has 4 types and not 16. So how it works with grass blocks is, like if you took the the 16 different types. Like if you generated the type, it would be for netherrack, and then you just took that 0 through 15 number and took that modulus by 4, you would just get this implement. It's grass type, or that's how I define it at least. And if you have that little bright pixel in the top left corner, and you're facing the north, that'll be the type 0. And if you have it in the top right, it'll be type 1. The bottom right, it'll be type 2, and bottom left, it'll be type 3. So for grass, it's quite a bit simpler. But what other blocks can we does this work for? And it turns out we can also do blocks like sand and even stone. But yeah, I didn't have any. I don't have any. What do I want to say? I was like spreadsheets set up for those types, and I don't have any specific methods for the sand or stone implementations. Sand and stone will still both generate like one of these 16 types, and yeah, if you know like what block rotation for each one of those is, you will be able to generate a unique like you could tell by using the faces. You can find the coordinates of an area using these two. Like as you could see on the stone block, these 3 pixels are on the right side on this one, but on this stone block they're on the left side. So yeah, if any of you guys really want to like do searches on these types of blocks, you could potentially do that too if you're willing to figure out what's what. Maybe set yourself up a little bit. So yeah, that's pretty much it. I don't know if I ever talked about it in this video, but yeah, this is mostly for reverse engineering coordinates from looking at some simple rotations of some blocks. Literally just if you have enough blocks, it should be enough to generate a unique formation, and then that could be the only location in the entire Minecraft world where that would generate. I did like a search, a million by a million search I was telling you about before, and yeah, and it was able to find like a 32 block face formation. So yeah, I'm pretty confident that should work on mostly anything you would want to check. Maybe things would be different if you have like a different texture pack or some other implementation. Or I know if you have Optifine, you can disable this. You could disable like block rotations. So yeah, maybe some people would want to do that. But yeah, I think that should be it for this video. Thanks for watching. Bye.